In today's video, I'm talking about intestinal permeability, histamine, and leaky gut. And we're going to talk about lab markers, things that you're going to see show up on labs that would indicate you may have histamine intolerance, that you have this condition of intestinal permeability and leaky gut. So if you're looking for the root cause of chronic inflammation, this is a key presentation to listen to. We're going to go on a deep dive here. And so when we look at leaky gut, we know that the enterocytes or the intestinal cells are really one cell wall, meaning that there's only one cell and it's connected. It's a strong, it's a stress resilient cell, but it's connected with tight junctions, right? These kind of little junctions, these proteins that connect all these cells, but it's only one cell that connects or that separates the intestines or what's inside of your intestines and your bloodstream. Now, right above that intestinal lining is your mucosal lining, right? Your mucosal membrane. And that mucosal membrane is where roughly 70 to 80% of your immune system lies. So you've got immunoglobulins. For example, one of the main ones is secretory IgA that lives in that gut mucosa, and it helps provide an immune response to keep the pathogen load, right? The bacteria, yeast, fungus, parasites, keep all of that under control and in check. And so that's the job of the mucosa. And it's also where a lot of different bacteria, in fact, we should have a lot of healthy bacteria, things like Akkermansia muciniphila, which is a keystone bacteria that is associated with lower levels of inflammation and better metabolic health. We should have high levels of Akkermansia muciniphila. What happens when we are, digesting our food effectively is we're producing enough stomach acid, enough bile, enough pancreatic enzymes, and we're breaking down the food particles into very small molecules that pass through the mucosa into the villi or little pockets in the intestines. And then they go into the bloodstream, right? Where they're carried to different cells of the body, and we're able to use them for new cell structures, for enzymes, proteins, and for energy production. The issue is that the gut junction, right, the intestinal lining, it's kind of like a cheesecloth, right? It's only supposed to allow nutrients through and keeps larger food particles and pathogenic microbes out. However, when we have inflammation, it damages, it reduces the amount of mucosa in the intestines, and then it breaks the tight junctions and allows larger particles, large undigested proteins, different pathogens, different cell structures, right? Different proteins involved in the intestines, right? So different parts of the actual intestinal lining now seep into the bloodstream. And these things are actually called, for example, there's endotoxins, like the outer layer of certain types of bacteria called lipopolysaccharides is one of these, right? That are called DAMPs and PAMPs. PAMPs refers to pathogen-associated molecular patterns. So these are associated, again, the body recognizes, hey, this is a component of a pathogen, of something that, is a threat to my survival, because we know that throughout the history of mankind, more people have actually died from systemic infections, bacteria, pathogens getting into the bloodstream, spreading into our lungs, causing pneumonia, spreading into our heart, causing myocarditis, or into our nervous system, causing meningitis and killing us quickly. So because of that, the body has hardwired this response called inflammation to keep the pathogen load under control. And so when we have a high level of PAMPs, pathogen-associated molecular patterns, or DAMPs, which are damage-associated molecular patterns, that's going to be proteins involved, for example, in the actual intestinal lining that get damaged from inflammation and then seep into the bloodstream, or large undigested food particles that the body doesn't recognize as food. When those are in the bloodstream, they're triggering inflammation. The body says, okay, we're in a place where we have trauma to our gut. We've got pathogens coming into our bloodstream. We're at risk of dying quickly. So we need to turn up inflammation throughout the body. And this is going to end up leading to issues with histamine intolerance that we're going to talk about as we go on. It's going to lead to perhaps autoimmunity or chronic inflammatory conditions, things like heart disease, cancer, diabetes, all associated with leaky gut or intestinal permeability. You have things like asthma, allergies, ADHD, mood disorders, dementia, all associated with damage in this intestinal membrane, leaky gut, and high levels of pathogen associated molecular patterns, these DAMPs and PAMPs, and damage associated molecular patterns. So those are DAMPs and PAMPs triggering up inflammation throughout the body. So we've got to get this under control. And, today we're going to talk about some of the major causes of gut inflammation. And we're going to talk about some biomarkers that we can look at, some lab tests that we can look at to see what our levels of gut inflammation are and what our histamine levels look like, right? If we have histamine intolerance or something like that. And so root causes of gut inflammation, of course, number one, inflammatory diet, eating too much sugar, processed foods, high fructose corn syrup, eating too many refined vegetable oils that drive up inflammation, all your corn, soy, safflower oil, canola oil, cottonseed, peanut oil, right? These are all rancid oils that drive up inflammation in the body. We also deep fry in a lot of these things and create really rancid fats that are highly inflammatory for the body. Trans fats, another big factor there, chemicals in our food, pesticides, herbicides, all these things drive up inflammation in the gut, turn up inflammation throughout the body. We also have food sensitivities. You may have a unique sensitivity to gluten or to eggs or to dairy or something like that. So food sensitivities could be a unique reaction that your body makes. Now, typically, when you develop food sensitivities, it's associated, there often is a genetic component to some of these sensitivities, like gluten, for example. However, when it's like something like eggs, it's usually because the person already has leaky gut, right? Food sensitivities are associated with somebody that's already dealing with this condition of intestinal permeability, and their body has hardwired an immune response to a protein involved, or a compound, maybe even lactose, involved with whatever food they're consuming, right? Now, again, some of these are genetic associated, like lactose. There are people that don't have the lactase enzyme. They don't produce that, and therefore they're not able to metabolize it. There are people that genetically are more hardwired to develop a gluten sensitivity. However, again, if you're having a lot of food sensitivities, that's going to be associated with leaky gut. Low stomach acid levels. We need to be able to produce really good stomach acid in order to break down and metabolize the food that we're consuming, and also to sterilize food that's coming in. Normally, at rest, the pH in our stomach is roughly around 3 to 3.5 pH. Now, in order to break down food, if you remember from chemistry class, the neutral pH is 7.0. That's what water is. To break down food effectively, particularly proteins like meat, we need to get that stomach acid from 3 to 3.5 down to about 1.5 to 2.2. So that's actually very energy demanding in order to do that. So we need to have the resources, the different compounds that we need, like enough chloride in our system, enough zinc, which is really important for the production of stomach acid. And then we also need energy, right? And we need what's called vagal nerve activation, which the vagus nerve is cranial nerve 10 that runs down from the brainstem into all of our viscera. And it's what turns on, it's the main parasympathetic nerve for the parasympathetic branch of our autonomic nervous system. And it's what turns on the production of digestive juices like stomach acid. So most people are not producing enough stomach acid because they're eating on the go. They they have nutrient deficiencies. They have chronic inflammation. All those things are going to block the ability to produce enough stomach acid. They can also have chronic infections like H. pylori infections or small intestinal bacterial overgrowth that can cause the inability to produce enough stomach acid. So gut infections are a really big thing. Parasites, they can also contribute to low stomach acid production. And then it becomes a vicious cycle, because now if we're not able to produce enough stomach acid, we're not able to break down food particles. We have larger food particles, and we're not able to reduce the pathogen load. And so therefore we have higher amounts of pathogens, higher amounts of DAMPs and PAMPs that are going to be accumulating, driving up more inflammation in the system. So it just becomes a vicious cycle until we address it and get it under control. Certain medications, things like nonsteroidal anti-inflammatory drugs, antibiotics, SSRIs can also impact your levels of gut inflammation. Steroids, different pain medications, stronger pain medications like Celebrex, things like that, all can, over time, using those can drive up more inflammation in the gut. If you're not producing enough stomach acid, you're probably also not producing enough bile and digestive enzymes. And also some people just have very congested livers, right? And their bile ducts in their liver are really congested and they're not thinning their bile. They have really thick, sludgy bile that doesn't move well and doesn't do the job of emulsifying fats effectively and sterilizing, right? Killing down, or, trimming down some of the bad bacteria in the small intestine and the pathogens in the small intestine. And so if you're not producing bile and digestive enzymes effectively, again, you're going to have more gut inflammation. And if you're stressed out, you're not sleeping well, that's also going to drive up inflammation in the gut. So these are some of the major causes of gut inflammation and things that you need to look at if you're dealing with autoimmunity, chronic inflammation, if you have gut problems, right, digestive problems. We have to consider all of these different things as we're looking at getting healthy. And so the different signs and symptoms, of gut inflammation in general, obviously irritable bowel syndrome, headaches, heartburn, nutritional deficiencies, a lot of brain issues, anxiety, depression, memory loss. If you have pain, a lot of, high levels of aching in your joints or inflammation in your joints, allergies, skin rashes, fatigue, of course, gas, bloating, diarrhea, cramps, psoriasis, a lot of skin issues can be associated with this. And so we have to look and consider all those things and tie them back to the gut. Hippocrates, the father of modern medicine, he's famous. One of his famous quotes, he has many actually, but one of them is, look well to the gut for the cause of all disease, right? Look at the gut. And so that is so critical. And when we talk about histamine is a compound that's associated with our immune system. And on top of that, it also helps stimulate the production of hydrochloric acid, right? So it helps our body it's necessary for producing stomach acid so we can digest our food effectively. It's also a neurotransmitter that helps regulate sleep, hormonal secretions that are associated with memory formation and brain arousal. And in the immune system, it acts as a vasodilator, right? And so it helps to dilate blood and allow for more immune cells to rush into different areas to, start to attack different pathogens or to break down tissue and prepare it for healing and repair. So histamine is a really important compound, and it's a compound that's very much associated with inflammation. So when inflammation goes up, we know histamine is going to go up. And histamine is metabolized by a couple different enzymes. The main one is called diamine oxidase, or DAO, and it's also broken down by histamine and methyltransferase, HNMT. So we need to have adequate amounts of these enzymes to metabolize it effectively. We should have a good balance. Histamine should go up for short periods of time and then be metabolized and come down naturally. And this natural response is healthy, it's normal, but there are some people that have high levels of inflammation and they're not able to metabolize. They have poor histamine metabolism. So therefore, they are stuck in this place, what we call histamine intolerance or histamine overload. And there are things like, for example, eating certain foods or even breathing in certain compounds that can drive more histamine production. We can also eat things or drink things that block the production of diamine oxidase. So we're not able to degrade histamine effectively. So we really need to consider those things if we're dealing with a lot of the symptoms of histamine intolerance. And there's a lot of overlap between histamine intolerance symptoms and gut inflammation symptoms. But the most common things that we see with histamine intolerance are going to be a lot of skin issues like eczema or hives. That is common. Also, a lot of brain issues, irritability, headaches, brain fog, right? Those can be issues. Also, irregular heartbeat, low blood pressure, heartburn, food allergies, a lot of gut issues, diarrhea, constipation can be associated with this. Seasonal allergies, very common, and this is you think about pollen is really a undigested protein, or it's a large unrecognized protein is what I should say. So when we take in pollen, normally we should be able to metabolize it or just recognize it as an environmental protein, not associated with a pathogen, not associated with danger, right? Or damage, tissue damage. And so therefore we should just, really just get it into our detoxification systems and kind of poop it out, pee it out, breathe it out, right? We should just kind of be able to eliminate it naturally without creating an inflammatory response. However, when our immune system is imbalanced, it tilts towards this place of inflammation, because again, inflammation is designed to allow us to survive, right? It's a survival mechanism. And when we're imbalanced, you got to think about it like not being able to see well, right? Let's say it's like you're walking and you're trying to go to the bathroom in the middle of the night and it's pitch black. You are, oftentimes going to walk very, very slowly. You're going to try to like put your arm out and touch a wall or something like that. You're going to be very cautious. Well, the body's the same way. It's the caution is I'm going to lean on the side of more inflammation because I want to make sure that pathogens don't kill me quickly. And so because of that, I'm not going to just, try to, because of that, I'm going to drive more inflammation when I see things that could be possible threats. And that's really what happens here with pollen. And so it drives up this histamine reaction. And if we're not able to degrade the histamine well, we end up with a lot of allergy-like symptoms. And so this is really common. And when we look at histamine intolerance, people that are dealing with this, oftentimes they have some genetic issues, but there's always intestinal permeability and leaky gut as one of the root cause factors. And then there are certain things that can provoke it. And that could be an environmental cause like pollen, like mold. A lot of times people that are dealing with histamine intolerance are living in moldy homes and they're constantly breathing in mycotoxins and molds that are driving up more inflammation. They may have consumed more alcohol than they should. They may not be sleeping well or under a lot of stress. They may have high estrogen, right? Women with high estrogen to progesterone in comparison to progesterone oftentimes will deal with more histamine-like issues. And so we need to be able to metabolize estrogen well, and that's a function of the liver. So sometimes supporting liver is actually really an important component to getting your histamine levels under control. And that's one of the things my team does, my health coaching team does when we're working with people with histamine intolerance. We support the liver. So important for helping to break down estrogens that we're getting from our environment, xenoestrogens from plastics, from can linings, from, perhaps personal care, personal hygiene products and cosmetics. And so we want to do our best, obviously, to minimize our exposure to different chemicals and those things, but also we need to support the liver and its ability to remove those things, deactivate them, and push them out through the colon and through the urine. So that's critical. There also may be nutrient deficiencies, vitamin B6, for example, things like copper, zinc. These things are important for healthy immune response. And if you're deficient in some of these, magnesium can be another one. If you're deficient in some of these, then you may end up having a higher tendency towards histamine, right? Or a higher histamine intolerance. Vitamin C, glutathione, those are other key nutrients that are needed to help prime your immune system and balance your immune system. And then for some people, again, they're eating a lot food with a lot of histamines and they have poor histamine metabolism. And so then we need to look at also reducing histamines in the diet, which are usually coming in fermented foods, leftovers, eating leftovers, things like apple cider vinegar could have higher histamines, right? It does have higher histamines that could provoke more symptoms. So those are things to consider there, and keeping stress under control is really important as well. Now, some of the factors when we look at diamine oxidase, again, we know that copper and B6 deficiency, we know copper and B6 are critical cofactors that enable DAO to degrade histamine, because DAO, again, is an enzyme that degrades histamine. So that's important. We know that small intestinal bacterial overgrowth, or SIBO, is very much associated with people that have histamine issues, right? So very important. Some of those gut microbes in the intestine will produce high amounts of histamines. And so we should have a lot more bacteria in the large intestine. Sometimes they translocate into the small intestine, or we'll have higher amounts of bacteria in our mouth that come down through the stomach, and we're not producing enough stomach acid, and they get into the small intestine where they colonize. and that can cause SIBO, which can, again, drive up risk of histamine issues. So that's key there. And of course, we know leaky gut, and then there could be a genetic polymorphism in the DAO enzyme, or you have a homozygous DAO, and that would make somebody more susceptible to developing histamine intolerance because you just don't have a good functional enzyme to break down histamine effectively. Certain medications, some of these we already talked about, but non-steroidal anti-inflammatory drugs like ibuprofen, aspirin can also block DAO production. Antidepressants, immune modulators, things like Humira, for example, antiarrhythmic medications, antihistamines, of course, associated with bringing down histamine, they can actually cause a poor histamine metabolism overall, and then histamine blockers as well. All those things can actually lead to kind of almost a lot of times when people are on some of those medications, they develop a habituation to them, right? Or an addiction almost. And then when they try to come off of them, they have worsening histamine responses because their DAO enzymes are so significantly reduced and they're not able to metabolize histamine effectively. So going to the lab work, key lab markers that we're looking at for intestinal permeability and histamine, we're looking at zonulin, and we'll talk more about that, lipopolysaccharides, which is one of the main endotoxins and one of the main pathogen-associated molecular patterns, those PAMPs that we talked about. DAO enzymes, which we've already been mentioning, histamine, and there's something called the DAO histamine ratio. And I'm going to show you what this looks like on a lab. And then there's some markers like elastase 1, which is actually an enzyme, right? And can be associated with leaky gut because it should be in our intestines and it can seep into, or it could be, you can have high levels of that in the stool, right? And that can be associated with leaky gut, poor pancreatic enzyme production, high levels of secretory IgA, which is an immune component, calprotectin, which is a component associated with inflammation, higher levels of inflammation in the gut, steatocrit, which is associated with fat metabolism. So if we have high steatocrit, oftentimes it's associated with poor bile flow, low stomach acid, poor pancreatic enzyme production, particularly lipase, the fat digesting enzyme. So these are all things that we can look at. Now, zonulin is a type of protein that's synthesized in your intestinal and liver cells. It helps to modulate the permeability of the intestinal lining. There are certain times where we actually want that intestinal, we want a little bit more increased permeability. And that would be like a time when we're in a time of famine, we're not consuming much food. And then we get food, we need to get the most amount of nutrient absorption. So we may have higher levels of permeability. But, when food is plenty and we have a lot of food around, we want lower levels. And so in our society, in a first world country, we want less permeability because it's actually better that we absorb a little bit less of the food or the nutrition that we're consuming, but get less toxins, less pathogens into our bloodstream. Therefore, we get less of an inflammatory provocation. So that would actually be better. So zonulin, higher zonulin levels, again, increase intestinal permeability, which increases your risk of leaky gut and chronic inflammation. So when we're looking at your zonulin levels, once it gets beyond a certain threshold, we know, okay, this person's got intestinal permeability that's taking place here. And then another marker we're looking at is LPS, lipopolysaccharides. This is the outer layer, right, of certain bacteria called gram-negative bacteria. And it's found in their outer membrane. And it's released into the bloodstream when they activate it, when our body, when it's released, it activates inflammatory pathways in the body. It's a very potent trigger of inflammation. And so when LPS is high, we know we've got high levels of inflammation in the system. So the histamine and intestinal permeability test is a test. It's a blood test that we offer on our website. And it's a very simple test. And it looks at your zonulin levels that we just talked about, that protein is associated with intestinal permeability. It looks at the LPS, the endotoxin, the main endotoxin that's the most well-researched endotoxin. The DAO enzymes, how much your body has and it's producing, histamine, and your DAO to histamine ratio. And so when we're looking at this, if you're watching on video, you can see that the zonulin levels here on this sample test, they shouldn't be over, the normal range is 0 to 5.2, right? Once it gets beyond 5.2 nanograms per milliliter, that's high. All right. Ideally, for the ideal range, it should be under 3. So when I'm looking at it from a functional perspective, I really want to see that under 3. If I'm seeing that up over 3, I'm considering intestinal permeability. Certainly anything up over 5.2, high, strong indicator for intestinal permeability in the body. And then when I'm looking at DAO, optimal DAO levels are somewhere up over 45, right? So it should be up over 45 nanograms per milliliter. The reportable range is 33.9 to 134.5. I've never seen this too high, so I wouldn't worry about that. But I like to see it up over 45. And if it's down under 45, definitely thinking, okay, this person's not producing enough DAO. So we can go back to some of those causes. Maybe they're taking some of those different medications. Maybe they've got SIBO that could be associated with lower DAO. Maybe they're consuming a lot of foods that block DAO production. And we have a whole list of them on our website. So you can look at that. And then when I'm looking at histamine, histamine should be under 2 nanograms per milliliter, right? It should be under 2. And ideally under like 1.25, right? So ideally I'm looking at it under 1.25 nanograms per milliliter would be ideal. Up over 2, certainly a sign of high levels of histamine. But then we're going to look at the DAO to histamine ratio. And ideally the DAO to histamine ratio should be up over 40. So that means, okay, we're producing enough DAO to metabolize histamine effectively. Now, somebody may still have high histamine and still have, they may have their DAO maybe 90 and their histamine is 2.1, right? So there's still a good DAO to histamine ratio, which I like to see DAO to histamine ratio up over 35, close to 40 if possible. So if they had their diamine oxidase, if that was 90 and their histamine was 2.1, histamine's high, it's going to be flagged high, but their DAO to histamine ratio is going to be up over 40. That would look good, but they still may have intestinal permeability. It just lets me know that they're producing enough DAO to metabolize the histamine. So that's a good thing, but we still need to address the intestinal permeability that's taking place. It just lets me know that they're not having like a histamine intolerance type of reaction, because their body can metabolize a histamine. It's just that they have intestinal permeability. They have leaky gut that's driving the higher amount of histamine. And then there are some other markers I like to look at. LPS, IgA1 or IgA, which is the immunoglobulin, right, in the mucosa to LPS, right? And so if that is high, your optimal range, a reportable range is 0 to 47.3. The optimal range there is going to be, it's usually, there's going to be some level of it. So it's usually about 7 to 14 is the optimal range. You can see in this example, this person's at 19.44. So they're certainly creating some sort of an immune response to it. Okay. But the IgA isn't as important as like the IgG. If the IgG is high, it's telling me, okay, this has been going on for a while. IgA is more of, hey, this is what's happening in the mucosa. So it's happening right now in the mucosa. So the mucosa is really battling higher levels of LPS. And that is important to know, right? It's important to know, but is it getting into the bloodstream? Let's look at the LPS IgG. That optimal range there is going to be between 45 and 80. If it's too high, or in some cases too low, that could be associated with inflammation there, right? And sometimes the immune system gets weak, right? So if your body has had high levels of inflammation for a while, sometimes it will produce less immunoglobulins, and therefore you may see a lower marker. Same thing with LPS IgM. IgM is more of an acute marker. IgG is more of something that's been going on chronically. So IgM is associated with blood. Same thing with the IgG, but IgM is acute. IgG is chronic. This has been going on for a long time. IgA is in the mucosa, not associated with the blood, right? It's the antibody marker in the or the immune marker in the mucosa. So that's what we're looking at there. Ideally for the LPS, IgM that should be ideally between roughly 12 and 26, somewhere in that range. So again, I'm seeing it high or low. I may think, okay, this person probably just has an overall weakened or lacks responsivity in their immune system. And that could be because they have chronic infection. That could have caused it. So when we're looking at if somebody does have like a high histamine to DAO ratio or high histamine levels, some things we may want to consider would be reducing the overall amount of histamine-rich foods. So again, I talked about fermented foods, vinegars, also cured meats like bacon, salami, pepperoni, all associated with higher histamine response. Soured foods, so sour cream, again, those are fermented foods, buttermilk, yogurt, things like that. Citrus fruits are a big one. Aged cheeses, like including goat cheese, nuts like walnuts, cashews, peanuts, different vegetables, avocados, right, which is fruit. Avocados and olives are higher histamine, and they're high fat, normally very healthy foods. But if somebody does have major issues with histamine, we might have to take those out for a period of time. Also, nightshades like eggplant, tomatoes, peppers can oftentimes be issues. Spinach can be an issue. And then there are certain foods that are more histamine releasing. So alcohol, avocados, like I talked about, bananas, chocolate, cow's milk, papaya, pineapple, shellfish, strawberries, tomatoes, wheat germ, right? So these things we want to look at. And of course, processed foods in general, we want to remove. Now, a couple other markers that I'll look at. So associated with that blood test, the histamine and intestinal permeability blood test, I look at a GI map, right? Where I can look at the actual microbiome. I can look at the levels of pathogens, different parasites, different types of parasites, whether it's amoeba or whether it's like a hemolyth, like a worm or larger one, or protozoa. So we can look at that. We can look at different pathogens. Blastocystis hominis is a common one that we'll see. We'll see H. pylori oftentimes. We'll see Klebsiella, different things like that that are pathogen associated bacteria that we'll see on the GI map. And also we'll look at digestion markers, things like alactase, which is digestive enzyme secreted by the pancreas. We know low levels are associated with low stomach acid, poor pancreatic function, possibly gallstones. Cystic fibrosis can also be an issue for some individuals. You know, when we have high alactase, you know, oftentimes, again, they know that they have cystic fibrosis beforehand. Low levels can also be seen with vegans and vegetarians because they may not be getting enough proteins to produce some of these enzymes. Enzymes are proteins. So we need to have enough protein and good protein absorption in order to produce enough enzymes. Steatocrit is a measurement of fecal fats. Its high levels indicate poor bile salt sufficiency, low stomach acid, poor pancreatic function. Can also be seen with things like celiac disease or malabsorption. It might be high as well. Now, again, stomach acid, I talked about earlier, I talked about how important it is and how it sterilizes food. It's important for protein digestion and assimilation. It's important for activating pepsin, which is an enzyme that degrades and breaks down protein. It activates intrinsic factor for B12 absorption, helps stimulate the delivery of bile and enzymes. Normally, the bolus or the digested food in the stomach is very acidic because we have enough stomach acid that really breaks it down, metabolizes it. And that acidic bolus moving into the pyloric sphincter, which separates a muscle, which is a muscle and a valve that separates between the stomach and the small intestines. As that moves into the pyloric sphincter, it triggers the opening of that sphincter, which then moves the food into the small intestine. Now, because the bolus is very acidic, it stimulates certain receptors in the top portion of the small intestine that then activate the production of bile. Bile is very alkaline, and that helps to alkalize the acidic bolus because the small intestine needs a very alkaline environment. It also triggers the release of bicarbonate from the pancreas, which helps alkalize the environment, along with the bicarbonate. So the triggering of the bicarbonate also triggers the release of pancreatic enzymes. So when we don't have enough stomach acid, we're not going to produce enough bile and enough pancreatic enzymes. So it's going to just go just like that. Low stomach acid is going to be associated with low bile and low digestive enzymes. So very important there. Good enough stomach acid is also very important for closing the esophageal sphincter, which is a sphincter that protects your esophagus from acid. That's really important for preventing against acid reflux and GERD. And it helps open the pyloric sphincter again, like I talked about, to move food through into the small intestine and further digestion. So some markers we're going to look at on blood for low stomach acid are going to be your total proteins. So normally it should be between 6 and 8.5 grams per deciliter. That's what your protein level should be. The functional range is 6.9 to 7.4, right? That's really where healthy people, that's where their total blood proteins are going to be. Okay. And those proteins are, immunoglobulins. They are, they're different blood proteins that we need for immune function, right? For albumin is another protein that's associated with this. And albumin is really important as a carrying protein to bring, nutrients to cells and to help carry. You have different carrier proteins, right? Thyroglobulin, is another one. So there's different carrier proteins that are needed, right, for moving things through in the blood. So this is really what we're measuring. When we're looking at low functional total proteins, we think low protein diet, liver dysfunction, low stomach acid levels. So if your protein levels in your blood are either high or low, I think low stomach acid could be one of the main contributors here. All right. That's one of the main factors with this. So blood urea nitrogen, or BUN, right? This is a marker as well. It's, a marker of how the body, it's the urea cycle and how the body eliminates ammonia, right? And it does it through urea excretion. The clinical range is 6 to 24 milligrams per deciliter, but the functional range for optimal health is between 13 to 18. A functional high can be an indication of low stomach acid or dehydration. So I'm looking at other markers for dehydration. Is the albumin high? Is the sodium potassium high? That could be dehydration. If I'm not seeing those things, then I'm thinking probably low stomach acid levels here. So especially if you see if you see the functional, again, high BUN and albumin, that indicates dehydration. A low BUN, right, if it's under 13, can indicate malnutrition, or you're not digesting and breaking down protein, because ammonia is a byproduct of protein digestion. So it can indicate malnutrition, celiac disease, or low stomach acid. So high can be an indication of stomach acid issues, and low, right? So just like total proteins, it's kind of the same with BUN. So that's what we're looking at there. Now, the low stomach acid pattern that I'm looking at on blood is going to be low total proteins. This is what I normally see, right? I rarely see high total proteins unless a person's on like a really high protein diet. Usually it's low total proteins under 6.9, low BUN under 13, low globulins under 2.4, a high albumin to globulin ratio over 2, low chloride under 100. Chloride is important for hydrochloric acid, right? For stomach acid. High MCV, or mean corpuscular volume, which is basically the volume of the red blood cell, because we know that stomach acid is important for B12 production, and B12 helps with the methylation cycle. And the methylation cycle is part of how the red blood cell matures. So B12 is critical for the maturation of the red blood cell. And during the maturation, the red blood cell actually starts out very large and immature. And then as it matures, it gets smaller, and it brings that mean corpuscular volume roughly between 85 and 92. So it's up over that. I'm looking at the possible issues with B12 absorption. Low phosphorus under 3.5, because stomach acid is really key for the absorption of different minerals like calcium, iron, zinc, phosphorus. You may see, low zinc, for example. It's a common one, under 90. Low B12, you might see that under 800. Low serum iron under 85. Low calcium under 9.2. So these are things that I'm looking at as a whole. I look at all of these to see, okay, am I seeing a low stomach acid pattern here on the blood work? And that's important to understand, right? And so you can actually look at your labs and see, okay, are these showing that I'm not producing enough stomach acid? And then you can support your stomach acid levels. And if you're not getting labs that are detailed or an analysis like this, if your doctor's just running regular labs, telling you, oh, everything's fine, no big deal, you know, they probably aren't trained to look at labs in this way. And this is why my team, my health coaching team, we offer this comprehensive blood analysis, which looks at all different markers involved in your immune system function, blood sugar and insulin levels, liver and kidney markers, inflammatory markers, zinc to copper levels, folate, vitamin B12 levels, your full lipid panel, parathyroid, thyroid, urinary tract health, right? All these things, vitamin A, vitamin D, your 25 hydroxy vitamin D and your activated 125 hydroxy vitamin D, which very few people run, but that's actually the activated form of vitamin D that actually stimulates the vitamin D receptor and activates the actual expression of vitamin D in the cells. So super critical stuff, super important stuff. You guys can check out the comprehensive blood analysis on our website. If you're watching it on video, we'll have a link below in the show notes, or if you're on the podcast, you're listening to the podcast, just go to drdavidjockers.com and look for the show notes here, or just go to our lab testing section. You'll see the comprehensive blood analysis. We also have the histamine testing, right? And that's a separate test, a separate blood test that looks at, you know, again, your DAO to your histamine to DAO ratio. It looks at your zonulin, looks at your LPS levels, right? All those things. And so you can get both of these and get a really good understanding of what's happening in your blood, your inflammatory markers, your stomach acid levels. We also offer that GI map if you want to really look at a deep dive of your microbiome, parasites, any possible bacterial infections, and the function of your digestive system. So check those out in the show notes, guys. And hopefully you guys enjoyed this. And we will see you guys in a future online training. Be blessed, everybody.